Okay, so in this question 2, we have a Venn diagram and some probabilities in there and X, Y, Z that we need to find. We're given the information B and C are mutually exclusive, A and C are independent. So from that first statement, B and C are mutually exclusive. That tells us that the intersection of B and C is 0. B and C cannot happen together, so there is no overlap. So that means that X is 0 and we can fill that in straight away. The other information that mutually exclusive gives us is this, that B union C, the probability of B union C is the probability of B plus probability of C. I'm not actually going to use that here at this point, although we can see that that would be true. So because that overlap is 0. Okay. Next, we're told that A and C are independent. So that tells us that the probability of A and C happening, the intersection, is equal to probability of A times the probability of C. Okay, so from this statement, we're now going to set up an equation using the information in the diagram. So A intersection C is Z in there. So that is equal to Z. Probability of A is everything in that circle, so 0.1 plus Y plus Z. And we're multiplying that by probability of C here, which is Z plus 0.39. We've already established that X is 0. Now at this point, I've got a single equation, but with 2 unknowns. So I know I can't solve that as it stands on its own. So I just need some other information. Now the other thing that we know is that all of these probabilities have to add up to 1. So over here, I'm going to have a look at total probabilities adding to 1. So if I write down everything that I can see there, 0.1 plus Y plus Z, that's all from A, and then plus 0.3 from B, and then from C, 0.39, and then plus this 0.06 outside. All of that has to add up to 1. I can simplify that. Y plus Z plus 0.85 is 1, so Y plus Z is 0.15. That's quite handy because I can actually pop this straight back in over here to Y plus Z. So instead of Y plus Z here, I've got 0.15, and now I can solve this. Z is 0.25 times that bracket, or a quarter of that, so multiply both sides by 4, subtract the Z, divide by 3, I found Z. Looking back at this equation then, Y plus Z is 0.15, means that I can find Y is 0.02. Putting those all back in probably to here, I could do a double check that all of those probabilities add up to 1. Okay, to summarise the key probability points that you need from this question, if we are told that A and B are mutually exclusive, this means they can't both occur at the same time, and therefore the intersection is equal to 0. It also means that their union is the sum of their probabilities. We can picture this in a Venn diagram like this. It sets A and B don't overlap, and if I want the probability of A union B, I simply add both probabilities together. The next information we're given is about independent events. So if A and B are independent, this means one does not affect the other. And we have this result. The intersection is the product. So the probability that A and B happen is probability of A times probability of B. Now you're used to doing this at GCSE. For example, the probability that I get heads and then heads, and I toss a coin twice, they're independent. I can just multiply a half times a half. We see the use of both of these in our tree diagrams. So for example, if I've got this, then I have independent events here. My first event, tossing the coin the first time, or the first coin, and then my second event, they're independent. So when I want the probability of getting heads and then heads, I multiply to give 1/4, and so on. I'm also seeing some mutually exclusive here. So I can get heads and then heads. That would be mutually exclusive from getting tails and then tails. So if I was after the probability of getting the same on both coins, I would have probability of heads, heads, or tails, tails, and then I could do a straightforward add of those. So this notation here is just formalising what you've done before in tree diagrams. If they can't happen together, then the intersection is 0, and the union is simply adding their probabilities. If they are independent, the probability of them both happening, we multiply their probabilities.